One more question taken from surface area volume, class 9th. The question says that the diameter of the moon is approximately 1/4 the diameter of the earth, and then we have to find the ratio of their surface area and the ratio of their volume. So what we can do, we can make two structure. Let's say I make this being the moon and taking one more sphere. Let's say this is earth, that's bigger than the previous one. Now I'm taking the radius of this using small r and indicating the radius of this earth as capital R. I can say that the diameter of this, I say the diameter of this using small d, and for this I'm using capital D. Since we have to find the surface area ratios, therefore we can use S for this and S dash for the surface area. Also, we need to indicate their volume. So I'm taking V as the symbol for the volume of the moon and this being the volume of the earth. So what we can say here, let's say this being the first one I took as moon and the next one, this is earth. Right. So what we can going to do is to obtain the first relation that is given, that is the diameter of the moon is 1/4 the diameter of the earth. So what we can write, diameter of the moon, that is small d, is equal to 1/4 the diameter of the earth, that is capital D. What next we can do here is, we know that we have to obtain the ratio, right, is S over is to S dash. The ratio we have to obtain over here. Similarly, we have to get V is to V dash. So since in the beginning only we are obtaining the ratio, transposing this 1/4, that means capital D to the other side, it becomes small d over capital D. As you know that radius diameter is twice the radius, so I'm replacing this small d with twice. As you know, this d is twice of the radius. Similarly, I can replace this with capital R twice, as the diameter is twice the radius. That is equal to 1/4. Later we can reduce this and we get the ratio as R over R is equal to 1/4. I'm going to mark this as equation 1. Now what next? We are going to obtain the ratio of their surface area and also ratio of their volume. These are the two things which we have to find out. Now let's say if I find the ratio of their surface area, what I can do here, I can write the ratio as S over S dash, replacing S with this formula of surface area, that is 4 pi r square, and similarly for the other part it is 4 pi r square. The first is for the moon, the numerator, and the denominator for the earth. Here 4 pi get cancelled. So this is S over S dash is R over R dash, and then we can place a whole square. What next? We are going to replace this R over R dash from this equation or this relation, that is 1/4. So we can write this as 1/4 and this square over it, and this will give you 1/16. 1/16. So the required ratio, that is S is to S dash, is 1:16. As for the first part, we got 1:16. Now we have to get the ratio of their volume also. So we'll be writing the same manner. We can write V over V dash, replacing V with the formula, that is 4/3 pi r cube, and below it is 4/3 pi capital R cube. Now we can reduce this. So that is V over V dash is equal to R over capital R cube. So it's V over is V first and then below it's V dash, right? So V over V dash is equal to, same way I'm replacing this R over R dash with 1/4. So this is 1/4 and there is a cube over it. That is V over V dash will give you 1/64. So we got the required ratio here. That is V is to V dash is 1:16. 64. This we got as 1:64. Now further, we can also conclude here that as the radius in this case is 1/4, right? The radius of the moon is 1/4, or we can say that the radius of this earth is 4 times the radius of the moon, but then the ratio of their surface area is 1:16. That means the ratio, that means the surface area of earth here is 16 times the ratio of the, sorry, the surface area of the earth is 16 times the surface area of the moon. And likewise, we can say that the volume of this earth is 64 times the volume of the moon.